In this video, we're going to walk through an example for calculating the small sample confidence interval for mu1 minus mu2. And again, we have a couple of assumptions that we have to make. The first is that the two samples are randomly selected in an independent manner from the two target populations. The second is that both samples populations are approximately normally distributed. And the third is that the population variances are equal. So we are assuming that sigma 1 squared is equal to sigma 2 squared. Now, for it to be a small sample, we also have to check to see that n1 is less than 30, which does not appear to be the case, or that n2 is less than 30, which does appear to be the case. So because n2 is less than 30, because n2 is 20, we can use the small sample confidence interval formula. Now the first thing that we're going to do, since we know we're going to need it, is calculate our SP squared value, so SP squared. And we have a formula for that, which is equal to our n1 minus 1 times s1 squared plus our n2 minus 1 times s2 squared all over n1 plus n2 minus 2. And if we fill in values for that, we get our n1 minus 1, which is 39. So we're going to 39 times our s1 squared, which is 3, added to n2 minus 1, so 20 minus 1 is 19, multiplied by our s2 squared value, which is 2, and then we're going to divide that by our n1 plus n2, so 40 plus 20 is 60, minus 2 is 58. So we get 39 times 3 plus 19 times 2 over 58. And if we keep going with our calculation, we get 39 times 3 plus 19 plus 2 is 155 all over our 58 value, which is equal to 2.67. So now that we have our SP squared, the next piece of information we need is our T of alpha over 2. So we have T of alpha over 2, and we have alpha is 0.05, so alpha over 2 is 0.025. And then we need it for the degrees of freedom. And if we look, our degrees of freedom calculation is n1 plus n2 minus 2. So we get T of 0.025 with 40 plus 20 is 60, minus 2 is 58 degrees of freedom. So 58 degrees of freedom. And that's going to turn into, for us, since our table doesn't have 58, we're going to have T of 0.025 with 60 degrees of freedom. We're just going to round up since 58 is pretty close to 60. And if we look that up in our T table, we actually get that value is equal to 2.000. Now we're just going to use these two different pieces of information that we have, our SP squared value and our T value, our T of alpha over 2 value, to calculate our confidence interval. So our formula for that again is x1 bar minus x2 bar plus or minus our T of alpha over 2 with our degrees of freedom, and multiplied by the square root of SP squared times 1 over n1 plus 1 over n2. And again, we'll fill in those values. So we get this is equal to our x1 bar minus x2 bar. So we have 8 minus 7 is 1, plus or minus our T of alpha over 2, which we figured out to be is 2. Then we're going to multiply that by the square root of our 2.67. So 2.67 times 1 over n1 plus 1 over n2. If we put that into our calculator, we get 0.075. And then if we finish up this calculation, we're going to get 1 plus or minus 2 times the square root of 0.2, which gives us 1 plus or minus 0.894. And that's how we calculate our confidence interval for a small sample when we're looking at mu1 minus mu2. It's the same confidence interval that we used before. We just need to get a different value for our T with different degrees of freedom, and we need to calculate a different sigma using our SP squared and multiplying that by 1 over n1 plus 1 over n2.